Okay, hello everyone. I hope you are using the QR code. I would like to remind you that if you haven't submit your topic to the Google Classroom, please submit your topic. It's topic for the presentations. Don't forget topic for presentation. Okay. Please submit to Google Classroom. I think the some topics already been um, taken. So I believe there are only a few topics left that you can choose, or you can find a new one, okay, aside from what I provided. Um, I think the topic for uh, analytic trigonometry has been taken. Okay. Um, topic about polar also taken. Topic about the I think there's one topic about algebra in general, but more about the factors. Okay. Topic about the comics. I think this is just involving the parabola and ellipse. Um, hyperbola heaven. Okay. Hyperbola heaven. Um, sequence. Factors. Factors. I think 2D. 3D. I think 2D factors only taken. Is have not taken. A sequence taken the sum or series haven't. So if you still not submitting your topic and maybe forget to submit, please keep in mind that some topics already been taken, so you need to choose one topic. Okay. Uh, and you can also choose from outside of all of this. Okay. As long as it is not really uh, describing more in class. Okay? Like for example, because I already told you more about exponent and log, so I think no need for that topic, unless that you think that there is some topics that still need to be explored. Okay, and you can choose that topic. But I think you can choose between this three. Okay, you can maybe from the 3D factors, because I think it's quite a lot. You can choose maybe one or two sections on these topics and focus more on that. Okay, I think that is for your presentations. Okay, so hopefully you guys already prepared and at least have some idea on how um, to bring those presentations into the video, and hopefully before the December 14th. So December 14th is the presentation. So before the December 14th, you can give me your video at least maybe on December uh, 10 or 12, or you can check the Google Classroom which dates that I prepared. I will make some announcement for submitting the file, and we'll be uploading the files into the YouTube, or just put in the Google Drive, and you can watch before our presentation started. So I want everyone to watch each other videos before we start. And when we start on December 14th, so this is presentation. Uh, I want the class to be having more discussion and more elaboration. Okay? And also after the presentation, I will adding something that may be missing, or maybe some necessary points. Okay? And also each students can also comments and make some questions, or some elaborate on the topics that been presented. Right? Okay, that's uh, the presentation. Okay. Okay, now for I think for the feedback, I think most of you already did a good job. I don't think I need to review that feedback for a while. Okay, I will continue for today's lecture. I will continue uh, the lecture on, we are on matrix now. Last time we are having this important property on matrix, okay? Okay, especially this one here, that on multiplication, matrix is not equal if you reverse the order of that matrix. Okay. Okay. And uh, to end this section, I would like to give you some idea the application. Okay. So the application of matrix. Of course, we can write a linear system and compute them easily. So we can we can rewrite equations, like for example, so we can write a matrix equation. This is a matrix equation. So if you perform the multiplications, we can have x minus y plus 3z is 4, and x 2y minus 2z is 10, 3x minus y plus 5c is 14. So we have this system of linear equations. And we can also representing this linear, right? So matrix, we can represent uh, so data, right, data. It can be any data that is linear, uh, maybe like a demographic, taking charts. Demographic can be like the general population, uh, to define the genders, blah blah blah, and we can define that proportions into metrics. Okay, it's like how many female, male. We can define which variables, okay, like in a linear equation, and then we can assign those linear equation into a matrix form. Okay, that's one of the applications. Another applications that is, I think, more related uh, to current technology is the computer graphics. Okay? So like my notes here. Okay, if you look here, I can write like a line like this. Okay? And draw a circle like that. If you take a look closer, it's still sharp. Right? It's still sharp. We don't see any noticeable like a noise in the line. You see the line is quite smooth. Right? But if you take zoom in, still it seems so smooth. Right? But if you are really zoom in into the closer look of this image, okay, probably you know that it is consists of pixels. Right? Like if you are uh, really aware of um, uh, how the graphics are improved, um, I think you guys are from um, born mostly 2000 something. Right? Yeah, the graphics before 2000s, like maybe from 90s or 80s, a computer from this year era. Uh, if you play like the old game like in your game watch, if you have heard that, or a Game Boy or a Nintendo, you will see the graphics is, if this is the person you have, and then so you will see something like that. And this is like, for example, this is a person face, and yeah, like a retro games. Okay, you see the graphics are really old, and you will see something square, like making some the line should be like this, but it's seeming having some we call this as this block square is a pixel, 1 pixel. And the more technology improves, the more pixels in the graphics. Okay? So for example, if I let you taking this image here, okay? This is actually a matrix representations. Okay? So if you look here, okay, you see that it has some certain black and white color in the grading color. Right? So you will see that it is taking different um, brightness from really white and really black. Let's say we have this 7 scale for colors. Okay? And if we represent these numbers here as a color, and we want to take the image, okay, and taking it into our system, okay, we can make the color scheme into our matrix like this. That means this one here is the last color. The higher number will be more black, more darker, or dark. Okay? It's darker here. 556. Okay? And you can look and compare with the original image like this, and you'll see how it performs. Okay? This is just an example. I'm not really um, uh, proportion very well, but I think it can be seen that we can uh, we can transform this. So if we take into some grids like this, like into some square like this, so if we make this into a pixels, okay, so if this block is 1 pixels, our image becomes like this. We'll transform into this, okay? And that's how you are So this is your real object. Okay, you take your smartphone, take a shot, and inside your smartphone there are something programmed in your smartphone, right? They need to transform the object that they capture, and then they transform, and then they need to transform into a digital image. Okay? And how they transform that, they need the matrix. Okay? They need the matrix here. Matrix, we call it that's a matrix transformation here, and then the outcome will be the digital image. That's why the more pixels, or like, I'm not sure how high the smartphone now has, like how many megapixels. Okay, so how many megapixels, like 10, or maybe 13, right? Maybe it's already can have a good shot, maybe higher than this. Okay, so the more pixels is megapixels. So we have like a grid that is cut by this huge number of megapixels that has um, transitions from a real object to digital image. Okay, or do you guys already know this, or do you know just now about this matrix applications? Have you heard before? Have you heard about the pixels on your smartphone before? Okay. So yeah, uh, so if you have a smartphone, when you take photo, remember inside those processor in your smartphone, uh, there are some certain process. Okay, it's called smart because they can process something, and they can have, like, they have brain to process. So that's why it's called smartphone. Okay. Okay, so that is the computer graphics. Yeah, you can check. I think just browsing the internet if you want to know more. Um, if we apply to more contrast, okay, or higher contrast, if you look here, it's more noticeable that uh, the black and white is so the one that has more dark in color is more clearly darker, and the white is become whiter. So it has a high contrast. So if you, I'm not sure. Usually there's a lot of software that is used for photo editing, right? So if you're already taking a shot and you want to have like uh, edit the white balance, okay, you want to more looking the white color that captured in your camera or smartphone want to be more brightful, you can slightly increase that, and the more realistic your camera can capture when you edit, it can be you can edit it more flawless, okay? And it's I think uh, you can differentiate between a good camera and a bad camera from those point of view. Okay, okay, that's just application for your information. Okay. Um, Next thing about matrix is, so now we are going into the basic of math. So today there will be no feedback. Okay, no feedback. So I will just show you the this computer graphics, and the we will go for the inverse. Okay, the inverse of matrices, because this is how we can transform the matrix, because we need to transform the matrix to do something like imaging like this. Okay? This is visual imaging. and using the matrix for transforming the real image to a beautiful image. And how we are doing that and those transformations, first we need to know how to inverse the matrix. That gets us so important. So to begin with, how we understand the inverse, we need to define the matrix identity or identity of matrix. So identity is this is the n matrix for which each main diagonal entry is 1 and all other entries are 0. And say if you have um, at least two by two matrix, okay? This will be resulting in this. Okay? This is the matrix identity. And we have 3 by 3. This will be okay. And you have 4, 5, 6. Will be having one in diagonal and the other part will be 0. And why we need to know this identity? Okay? And because the important property for this identity is if we have matrix A, also let A be a matrix uh, and B be matrices. When we have matrix identity, when we multiply A with some identity matrix, okay, it will be just taken original A. And we have identity multiplied by A or multiplied by B, it will be resulting B. Okay. Whenever the products are already defined. Okay? So every matrix that is multiplied by identity will be the original matrix. Okay, that's the important point. So this is the and if A multiplied by B, okay, if this is the same as B multiplied by A, and this is the same as matrix identity, then we can say B is the inverse of A. Okay. So let me put this here and make it a little bit smaller. Let's visualize this. Okay, I can just. Okay, so the inverse that. Okay, so the inverse of matrix. So if we let A be a square and by n, so it's the size of row and column should be the same. Okay, and n matrix. If exists and matrix A inverse, then the property should be resulting the identity. And we say that A inverse is the inverse of A. This is just to confirm that, okay, it's true that A inverse is inverse of A. Okay, so we define the identity first. That is a matrix with the main diagonal entry is 1 and the other entry is 0. That's the identity. Because when we have that 1, 1, 1, when we multiply with any matrix, it will be resulting just that matrix. Okay? So when we have matrix A, matrix B, if it is equal B multiplied by A, the result should be the identity matrix. Okay, now let's see the example we have. Okay, if A is, this is example for verifying the inverse. So if A is that matrix and B is 2, okay, let's check the A multiplied by B. Okay, let's write down. So 6 minus 5 is 1, and minus 2, minus 2 minus 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 2 plus 2, 0. 15 minus 15, 0. And minus 5 plus 6 is 1. So it's the identity. And if we check the BA, it should be the same. Should be the same. It should be the same. If you check, negative 10 plus 10, 0, 3, 3, 0, negative 5 plus 6 is 1. So it's also the same. So we say that B is inverse of A, or A is inverse of A. Okay, so if we look at here, okay, between A and B, of course there is something interesting behind the number and the order here, right? Let's write for this 2 by 2 matrix. So inverse of 2 by 2 matrix. Okay? We start from the simple one. Let me write just the definition first and what is the formula of the inverse. So if A then inverse, this is the determinant, AB minus BC, and we slightly change the order, so this is become D, A, and this is still B, but taken the negative. Okay. So if we want to confirming the or let me write here first. So this is called determinant. And it need to be exists. Okay, need to be exists. If it is 0, then inverse matrices. Okay, and the examples of A is 4, 5, 2, 3. We want to find the A inverse. Change the A and B, and I can this here, and then this is and half, and then put half inside if we want, and this will be our matrices. And we can also check this and multiply our original inverse if we want to check. Okay, uh, 3 over 2, 4, 6. 6 minus 5 is 1. Minus 4 plus 4 is okay. It's 0, 0, 1, 1, 0, 0. It's our inverse. So inverse is okay. Okay. Another way to look this, okay, because we know that the identity is, let me make some line here to make some additional notes. Okay. This is just to remind you what we have learned before and how we connect this inverse with the linear equations that we are already applied, like the Gaussian elimination, the Gauss-Jordan, and everything. So if you remember that uh, if we can take this, for example, this matrix, this A matrix here. If we want to make this become this, okay, we can take some operations here and take some Gaussian eliminations and make it, and we want to make this into 1, 1, 0, 0, and this will be okay. And the one that is resulting on the right side here, this will be the inverse. Okay, so you can do like maybe how to make this 4 becomes 1. Maybe we need to divide by 4 first, or maybe we start from this 2 to make it 0. How we make it 0, right? So for example, if we want to multiply by 2, 4, and we start to subtract, we can write, maybe first we can divide by 4, 1, 5 over 4, 1 over 4, 0. Okay. And then second, this one, we can take this uh, and make this 2 subtract 4. So 2 by 2 minus 4 is 0. 3 by 2, 6 minus 5 is 1. And then this is 0. 0 multiplied by 2 is still 0. Minus 1 is minus 1. 1 multiplied by 2. 1 multiplied by 2 is 2. Minus 0 is 2. Okay. And then, similar way, we can take the first one and subtracting the 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 row 2. Okay. Okay, let me, maybe I will erase this part first. Okay. And take this upwards, and let's do some operations for Gaussian eliminations. Okay, so if this second step, okay, and the third step, I want to have this 5/4. I want to make it into 0, so I need uh, to minus with the row 2. Maybe I will multiply this with 5/4, and then I've subtracted. I think that is applicable. So first is 1, still 1, and then this will be 5/4 minus 5/4, so it will be 0. Okay, 1/4 minus 5/4, so 1/4 plus 5/4 is 6/4, or 3/2. Okay, and 0 minus 5/2, so minus 5/2. Okay, and still same below, write the same thing. Is it the same inverse? It's the same inverse. Okay, the same inverse, okay, so you can think as this method as well. Okay? So there is no like separation between this chapter 10, so everything are all connected. So that's how I want you to look at the chapters. Okay, so if we have, okay, this is the 2x2 matrix. Okay, if we have the 3x3 matrix. Okay, let's say we have the 1, -2, -4, 2, -3, -6, -3, 6, 15. If this is A, if you want to find the A inverse, we can take this and take it into 1, 1, 1, 0, 0, 0, 0, 0, 0. Okay, try this at home, and I will explain later, maybe next week. Okay, how we can find the inverse using Gaussian elimination is we want to make the left part is 1, 1, 1, 0, 0, 0, 0, 0, 0. Okay, and the right side here, after some computations, just like we did 2x2 matrix, this will be your A inverse. Okay, now after we learn this inverse using the Gaussian, then we can go for I think some of you already know how to find the inverse of this matrix using some formula. Okay, some formula, how to use that, and later we can discuss. I think for now we can find through this eliminations. Okay. And I think we can do that easily as long as, for example, here, I think you can start by finding this -2 and -4, take it to be 0, right? We can start from the -2 first. Okay, it will be -2. We need to multiply by 6, or multiply by 3 to become -6, and then plus with the third row. I think we can take it to 0, right? And also the -3 here, we need to make it 0 because it's already 1. And the top left, we can plus 3 and to make it 0. Okay, so try that at your home, and hopefully you guys can have familiarity with this Gaussian formula or Gaussian method, like from the previous sections, and you can find the inverse through that Gaussian method. Okay. So that's the I think I will end the lecture today. No feedback time. We will continue next week. Hopefully, we can finish the chapter 10 on next week. Next week is It's already 7. So 7 December, that will be, I think I will finish chapter 10, 7 and 8. Okay. Okay, I think that's all for today. Okay. So thank you for coming for the lecture today, and see you next week. Okay. And don't forget, for I think 2 or 3 students that haven't submitted the topics on the Google Classroom, check your Google Classroom. Check your sections about PBL informations. That is, I think you need to submit your topic, and I think 9 or 10 students only submit the topic, and I think that's already okay. And if I don't, if I am not commenting on your topics, that means that you can go on with your topic. If I comment that you need to change blah blah blah, then you need to find. And I think most of you already uh, have the topics and ready to move on for the next step. Okay, I think that's it for today. So thank you for coming. See you next week. You're welcome. Okay, you're welcome. And hopefully you can have a good semester and enjoying January for vacations or holiday. Okay. See you again.